Bismillahirrahmanirrahim. Today we are working with the partial fractions when the denominator has repeated irreducible quadratic factors, means that there will be quadratic terms in the denominator and those would not be reduced to linear factors. Means it would not be possible for such denominators that they can be converted into the linear form. So we will learn that how to make the partial fraction for these type of questions. Identification, you can see that the rule is written that if a quadratic factor is written in the form of ax square bx plus c, where a should not be 0, occurs twice in the denominator, means that it would have the power denominator with the power uh, raised to the power 2 or raised to the power 3 when there will be a quadratic term in the denominator. So we can start from the question number 1, which says that in the denominator we have x raised to power 2 plus 4 and then its higher power is 2. So this would be a case, means quadratic in the denominator and with the higher power. So the pattern says that we will make the partial fraction in this form, that ax plus b divided by quadratic term with first power 1. Then because it contains higher power of the quadratic, so next term will become cx plus d form over x raised to power 2 plus 4 whole square. This is how we will reduce the factors in the form of partial fractions, and then we will go and solve for it. The procedure is same as we have done for the previous parts, that we will take first LCM, and the LCM will be x square plus 4 its whole square. It will be the LCM, and x raised to power 4, x square plus 4 will be cancelled with 1 power of x raised to power 4, and the LCM will become ax plus b into x square plus 4. While for the second term, cx plus d will be in the denominator, because x square plus 4 whole square will be cancelled with the denominator, and we will be having same term on left hand side as mentioned in the start of the question. Same term. So once we will operate the LCM and we will get the arrangement, we will go for the cancellation and we will form the equation x raised to power 3 ax plus b into x square plus 4 plus cx plus d, and we will label it as equation number 1, because we do not have any linear part in the denominator, and in the normal procedure we were equating the terms and then we were equating the linear term, putting value of x in the equation number 1, we were able to get the answer. But now we don't have any linear factor in the denominator, so in that case we need to expand the terms on right hand side of equation number 1. So we will proceed from equation number 1 directly, and we will start multiplication for the sake of expansion. It will be a into x raised to power 3 plus 4ax plus bx square plus 4b cx plus d. it is x raised to power 3. Now, once we will compare the terms on left hand side and on right hand side, we need to have first we will take up x raised to power 3 common, but just to write the terms in the order, terms involving x cube first, then terms involving x square, then terms involving x only. So one is 4ax, other one is c. So we will take up x common, so we will have 4a plus c. And finally, we will have constants, that is 4b plus d. While on left hand side we have x raised to power 3, we don't have any term involving x square, we don't have any term involving x, so we will write them 0 time x square plus 0 time x and plus 0. So once we will go for the comparing coefficients of x raised to power 3, x raised to power 2x, and constants on both sides. On both sides. So this method give us the equations for the comparison. So we can notice that x raised to power 3 on left hand side is equals to 1, and on right hand side x raised to power 3 as a coefficient as a. So it would be the second equation. Then if we compare the coefficient of x square on both sides, left hand side the coefficient of x square is 0, but on right hand side the coefficient of x square is b. So means that b is equals to 0. You can even label it as third equation. And we don't have any coefficient on left hand side for the coefficient of x. So we will equate 4a plus c equals to 0 as well. This is equation number 4. And finally, we have constant terms that says 4b plus d equals to 0 again. So this would be equation number 5. So we cannot directly find the answer by putting the value of the variable, because we don't have any linear factor, any term which contain x raised to power 1 in the statement of the question. So that's why we will have to get the values by making equations. So we will notice that the value of a is directly obtained, value of b is also directly obtained. So now from equation number 4, we will just substitute the value of a to find the value of c. So c will be actually equals to minus 4 times a from equation number 4, and a is equals to 1. So finally the c will become minus 4. Similarly, from equation number 5, we will substitute the value of b, that is 0 is equals to 4 times, because b is equal to 0 in the second equation. So correspondingly d will also become 0. So all 4 alphabets are calculated. C is equals to minus 4, D is equal to 0, and A and B are already calculated. Now we just need to put the values in the original form. That was the original statement of the question. Substituting the values of A, B, C, the statement says original statement. So now the values of A, B, C, D will be substituted in this equation. According to this, a is 1, so it will be 1x plus b, b was 0, divided by x square plus 4 plus value of c is equals to minus 4 and d is 0. Substituting the values, we will be getting the required answer. So this is the final answer, means x over x square plus 4 minus 4x over x square plus 4 whole square. And left hand side is a statement of the question, which is x square plus 4 whole square. So it is the answer of the entire question. So for question number 2, we will notice that one term in the denominator is linear, while we have one quadratic term with higher or repeated powers. The process will be completed in such a way. First, we will investigate that is it a proper fraction or improper fractions. So for that purpose, we have to see that the maximum power in the denominator can be x raised to power 5, because once we will expand this term, we will be getting x raised to power 4 as highest power, and we have 1x plus 1 in the linear term. So once the two terms will be multiplied, it will become x raised to power 5. That will be highest power in the denominator, x raised to power 5. While in the numerator, we will see that the power of x is x raised to power 4. So numerator degree of the power is less than the power of the denominator. So that's why it is very much a proper fraction. So we will start the partial fractions. For that purpose, we will begin with the linear parts partial fraction. And whenever the linear term is involved, we write single alphabet like a over x plus 1. For quadratic, we would write bx plus c divided by x raised to power 2, x raised to power x square plus 1. Then we would write dx plus e divided by x square plus 1 whole square. So because it contains highest power 2 right here in the denominator, quadratic factor or number or a part in the denominator with higher powers. So whenever the higher powers of quadratic terms are there, we break up the fraction in this form. Quadratic terms x square plus 1 and x square plus 1 whole square, it will be always written in this format. So this is a type number 4 of the partial fractions, when we have repeated irreducible quadratic parts, means that those cannot be converted into the linear factors. So this is the requirement. So once we will start, and we always start by taking LCM. So again, we will take up the LCM in this part, and LCM will be one linear factor and the square of the quadratic part. A times x square plus 1 whole square, bx plus c into x square plus 1, and one more part will be here, x plus 1, and finally we will have dx plus e into x plus 1. and this is the step of LCM, which we take in all questions as a first step. If the fraction is proper fraction, the first step we do is in the form of LCM. We will keep the term in numerator and denominator as usual. Like this one. And once the LCM is operated, we will recheck the terms because it is the first step. If it is wrong, then the rest of the question will be wrong. So what we are going to do that we will recheck the LCM because x plus 1 is the first term in the denominator. It will be cancelled with the term in the LCM, and x square plus 1 whole square will be multiplied with a and will be written right at this place. So this is perfectly all right. B x square plus 1 will be cancelled with 1 power, and these two both parts x plus 1 and x square plus 1 will be multiplied with bx plus c in the numerator. And finally x square plus 1 whole square will be cancelled with x square plus 1 whole square. So x plus 1 and dx plus e, these two parts will be used for the sake of the multiplication of the LCM. And then as usual, these two parts will be cancelled out on both sides, and we will be having a term like x raised to power 4 3x square plus x plus 1, and on left hand side we will be having x square plus 1 whole square plus bx plus c and x square plus 1 x plus 1 as it is dx plus e and x plus 1. So as we have one linear factor, we will label this entire equation as equation number 1, and then we will put first linear factor because it is written in the question. So we are able to take its value. X is equals to minus 1 in equation number 1. So we will be able to get one alphabet because we need to find 5 alphabets A, B, C, D, E. So at least one can be obtained from equation number 1. So we are substituting value of x. So carefully substitute the value where there is x, write minus 1. And in the next step, we will solve it. So substituting the value of x, it will make it minus b plus c. We are substituting value of x minus 1 at all the places. Minus 1 plus 1. So from this step, we will see that few terms will become 0. As we can notice, minus 1 plus 1 will become 0. This entire part will become 0. So we will be having only a, that is minus 1 square will become 1, and there is a whole square over it, plus all these terms will become 0. On left hand side, minus 1 raised to power 4, which is an even power, it will make it plus 1. Again, minus 1 square will become plus 1 multiplied by 3, and this minus 1 plus 1 will be obviously cancelled. So we will have 4. 2 square means again 4. So a will be 4 by 4, that is equals to 1. So we have obtained the value of one alphabet, that is a. Now we don't have any other linear factor, so we need to expand equation number 1, and then we will make further equations to find values of a, b, and b, c, d, and e. So without wasting any time, we will go for the expansion of equation number 1, and then we will collect the similar terms on left hand side to do the comparison of the coefficients. Let's start from expansion on right hand side. We need to expand the whole square of first term. So always remember that whole square of two terms is expanded with the formula of a plus b whole square, which returns three terms in the expansion. Similarly, for second term bx plus c, we don't have any square involved in the whole square involved in this part. So we will simply multiply these two brackets first, and then later we will multiply with the bx plus c. So what multiplication will give us x is to power 3 plus x square plus x plus 1, and then dx square plus dx, and we will be having ex plus e. Now we need to multiply a inside. A raised to power ax raised to power 4, a plus 2 ax square. Now bx will be multiplied with all the parts inside this bracket. So it will make it bx raised to power 4, bx raised to power 3, bx square, and bx only. Then c will be multiplied. I would write it in the next line. It will become cx3, cx square plus cx plus c, and dx square, dx plus ex plus e. Whereas the terms on the left hand side are x raised to power 4 plus 3x square plus x plus 1. Now we need to collect the similar terms on right hand side. It will be x raised to power 4. We don't have any term. Okay, we have one term a and the other term b that we can take out common. So this is ax4 and bx4. Take out x raised to power 4 common. Now c we can take up common x raised to power 3. So we have one this term bx3, one cx3. So we would write it as b plus c. Then we will take up x square common. Then the term involving x square is 2a plus b plus c and plus d. Next will be taken as x common. So we will have b, this is bx, and then we will have one term c, one term involving d, and one term involving e. And lastly, we will have constants like a, this one, and constants without x, the terms involving without a plus c plus e. So this is the expansion on right hand side, and on left hand side we will have x raised to power 4, 3x square plus x plus 1. So we will go for the comparison as usual, comparing coefficients of x raised to power 4, x raised to power 3, x raised to power 2, x, and constants. So we will compare a plus b will be equals to 1. It would be second equation. Then x raised to power 3. We don't have any term on left hand side involving x raised to power 3. So we will write it as b plus c equals to 0 because there is no coefficient, no term involving x raised to power 3 on left hand side. We will label it as b plus c equals to 0, equation number 3, and the term involving x square 2a plus b plus c plus d equals to coefficient of x square, that is 3. So we will equate it equals to 3 and we will label it as equation number 4. Finally, we will have b plus c d plus e equals to coefficient of x, that is 1 on left hand side. This is the coefficient of x is 1 right here. So we will equate it, it will become 1. So this is equation number 5. And lastly, the constants a plus c plus e on right hand side, on left hand side, there is a constant 1. On right hand side, a plus c plus e is the coefficient of the constant term. It is equation number 6. So we have already calculated the one value of a, that is 1. So we will substitute in equation number 2 the value of a, that is 1. And from here we will be able to get the value of b. A is equals to 1 minus b is equal to 1 minus a. 1 minus 1 is equals to 0. So b will become equals to 0, that we have derived from the equation number 2. Now from the third equation, b is equals to minus times c, rather minus b, and b is equal to 0. So consequently c will also be 0. This is from the third equation. Now if we use equation number 4, a is equals to 1, we have already calculated. B, C both are 0, we have calculated. And D is required to be calculated. So D will be actually 3 minus 2. This is equals to 1. So we have calculated the value of A, B, C, D. Now only 1 is left. So we can get it from equation number 6, which is more simple. So E will be equals to 1 minus A minus C. A is equals to 1 and C is 0. So altogether E will become equals to 0. So we have calculated the value of A, B, C, D and E. Now to conclude the question, we need to do a slight small correction, that in this part the value of constant is 1 right here, which is by mistake is written as x plus 1 whole square, and same correction will be done right here, that is 1 whole square. So it is the correct answer.